Hello, Math Studies students. Welcome to another online lesson. Last class we talked about writing equations of tangents to curves, which again is writing the equation of a line that goes through one specific point on our curve, and we wrote those equations. Today we're going to continue that discussion, but talk about writing the equations of something known as a normal. And our goal is to be able to write the equation of the normal at any point of a basic function. So, to start with, we need to define what a normal is. A normal to a curve is once again a line that is perpendicular to the tangent at the point of contact. So, let's draw a picture here. If I have a quadratic function, or a parabola, and I have a specific point, and I draw the tangent to that, the normal, which I'll draw here in blue, is going to go through that exact same point, but it's going to be perpendicular. As we should know, perpendicular means crosses at 90 degrees. So it's just goes through the same point, but it's perpendicular to our tangent. That's what a normal is. How do we find a perpendicular slope? Well, we should have learned this back maybe freshman, sophomore year, maybe even earlier, 8th grade or 7th grade. But if our slope is given, our perpendicular slope is the opposite reciprocal. The opposite reciprocal. What I mean by that is, let's say our slope, our m was 2, then the perpendicular slope, and we use the symbol upside down capital T to mean perpendicular. So the perpendicular slope would be the opposite. Well, what's the opposite of 2? The opposite of having 2 is taking away 2, or negative 2. And then the reciprocal, we flip it like a fraction. Well, 2 is a whole number, so it's like 2 over 1. So the reciprocal would be 1 over 2. So if our original slope or our tangent equation had a slope of 2, our normal would have a slope of negative 1/2. Let's do another example. If I had a slope of 2/3, what would be my opposite reciprocal, or my normal slope, my perpendicular slope? And once again, I do the opposite. It was positive, so I make it negative, and then I do my reciprocal, so it becomes 3/2, so negative 3/2. One last example. If my original slope was, let's say negative 12, what would be my normal slope, or perpendicular slope? Well, the opposite of a negative this time would become a positive, and the reciprocal of a whole number 12 is 1 over 12. So those are examples of finding perpendicular slopes. But again, 2 words, opposite, reciprocal, 2 steps. Switch the sign and do the reciprocal. Now, what do we need to write the equation of a line? Well, this is just like writing the equation of a tangent. We need a point and a slope. And we are going to, again, use our formula for point-slope form. Y minus y sub 1 equals m times x minus x sub 1. So remember, this time our slope will not be directly from our derivative. It'll be our derivative slope, which is the tangent slope, but then we do the opposite reciprocal of that. So to start with, these are the same problems that we looked at on the last slideshow, except this time we're going to be focusing on normal. So for this first one, I want you to find 2 slopes for me. I first want you to find the slope of the tangent line, not the equation of the tangent line, just the slope, and then the normal as well. So in this unit, how are we finding slopes, or how do we find the slope of a function that isn't linear? We need to do our derivative. So if f of x equals x to the 4th power, then f prime of x is going to equal 4x to the 3rd power. Now when x equals 3, our slope is going to be equal to 4 times 3 to the 3rd power. 3 to the 3rd power is 27. 27 times 4 gives me 108. So my slope, when x is 3, of my tangent line is 108. But if I want to find the normal, I need to do the opposite reciprocal of that. So if my original slope is 108, my perpendicular slope is going to be equal to the opposite, which is negative, and then the reciprocal, which is 1 over 108. Again, if it's a whole number, We just put it in the denominator under a 1. Let's try this next one. So I'm given a function f of x equals 2x squared plus x plus 2. To find my derivative, just use my shortcut, can find it in seconds. It becomes 4x plus 1. To find my tangent slope, I plug in the x value of -1. So f prime of -1, or my slope when x is -1, becomes 4 times -1 plus 1, which is equal to -4 plus 1, which equals -3. So my slope of my tangent is -3. However, the slope of my normal is going to be the opposite reciprocal of that. The opposite of a negative is a positive, and the reciprocal of 3 is 1/3. Last but not least, 6 over x squared is my function. So if f of x equals 6 over x squared, I first need to rewrite that so that I can do my derivative. I want to write it as 6 times x to some power. There was an x squared being divided, so I write a -2, so 6x to the -2nd power. Now it's ready to do a derivative of it. Bring my exponent out front, it becomes -12. Lower my exponent by 1, it becomes -3. But I don't want to leave negative exponents in my answers, so I write that as -12 over x to the 3rd power. Now I want to find my tangent slope, so I plug in a 2. So I have -12 times 2 to the, well, actually, let's use my new equation without the negative exponents. Will make life much easier. So I'm going to be using this equation here. So I'll have -12 divided by my input, which was 2 to the 3rd power, which becomes -12 all over 8. That reduces to become, 4 goes into both of those, so we have -3/2. Now my perpendicular slope, or my normal slope, if I have -3/2 as my original tangent slope, I switch the sign and I end up with 2/3 once I do my reciprocal. So that is a review of finding the tangent slope, or the slope of the tangent line, and then now we're also doing the slope of the normal line, or the perpendicular slope. Now let's try writing some actual equations. Again, the process is going to be the exact same as our last slideshow where we focused on tangents. We just have to remember one extra step. Once we find our slope, do the opposite reciprocal. And we do that before we plug it into our point slope form. So I've got y equals x squared plus 2x minus 1. Our derivative here, y prime, is going to be 2x plus 2. I need a point and a slope. To get my slope, I use my derivative. My x equals 3. And so y prime, or slope, is going to be equal to 2 times 3 plus 2. So my y prime, or my slope, equals 8. However, I'm not going to use 8. I want the opposite reciprocal slope for a normal. Because again, we are writing the equation of a normal here. So the opposite reciprocal slope is going to be opposite of a positive is negative, and then the reciprocal of 8 is -1/8. Now we also need a y value here. We have the original x. We plug it into the original equation in all of these x's to find a y. Again, the equation is called y equals, so that'll help us find our y here. So y is equal to 3 squared plus 2 times 3 minus 1. So we end up with 9 plus 6 minus 1, which gives us 14. So our ordered pair is 3, which they gave us, comma 14, which we just found by plugging into our original equation. Our slope for our normal, or our perpendicular slope, is going to be equal to -1/8. Now we plug that all into point slope form. To remind us, it's y minus y sub 1 equals m times x minus x sub 1. So we have y minus 14 equals -1/8 times x minus 3. Now technically we've written the equation of a line, but We want it to be in slope-intercept form usually, so we're going to distribute, and here is some fraction practice. So we have y minus 14 equals negative 1/8 x plus 3 over 8. Again, I got a plus because this was negative and this was, and I'm distributing to both of these terms here. And remember, multiplying fractions is easy. We just go straight across, and you can make this into a 3 over 1. Now we have one last step. We want to get our y alone, so we add the 14 to both sides. Again, feel free to use your calculator if you need to, but we'll end up with y equals negative 1/8 x, and then 14 times 8 is 112, plus 3 more that we have there, so that's 115 all over 8. Let me double check my work there. Again, I need to have a common denominator here to add the 14, so I want to have it over 8, so I'm multiplying 8 to both the top and the bottom here. It's like 14 over 1, and 8 times 10 gives me 80. 8 times 4 is 32. Add those together, 112, plus the 3 up here. Yep, 115 over 8. And that would be the equation of my normal. Once again, what's a normal? If I have a curve, if I have a tangent line, the normal is the one that cuts through it perpendicularly. One last example. Write the equation of the lines that are normal to the equation y equals x cubed minus 2x squared plus x minus 1 when x equals 2. And there's a typo there. We don't want equations. We just want a single line that is normal to the equation. All right, so the first thing we're going to do here is our derivative. You could also start by plugging in x to find your y, but we'll do our derivative first. 3x squared minus 4x plus 1. Now to find our slope of our tangent, we can plug in into our derivative here. We're going to plug in a 2. And we end up with 4 times 3, which is 12, minus 8 plus 1, which gives us a slope of 5. That means our perpendicular slope, or the slope of our normal, is going to be negative 1/5. We still need a y value. We take our original x and plug it into our original equation here. And so we will end up with y equals 2 to the third power minus 2 times 2 squared plus 2 minus 1. And that will give us 8 minus 8 plus 2 minus 1. These cancel out, leaving us with y equals 2 minus 1, also known as 1. So our ordered pair is 2, 1. Now we need to write our equation of our normal. Y minus y sub 1 equals our slope, which will be our perpendicular slope, times x minus x sub 1. Our y value is 1, so y minus 1 equals our perpendicular slope, which is negative 1/5, times x minus 2. We're going to distribute our negative 1/5. So we have negative 1/5 x, and then a negative times another negative becomes a positive. Multiplying fractions is easy. Go straight across. 1 times 2 is 2. 5 times 1 is 5. That all equals y minus 1. To get y alone, we need to add the 1 to both sides. So add 1 here, add 1 here. We once again need a common denominator. So if I'm adding 2/5 to 1, I need to make this 1 into a fraction, 1 over 1, multiply the top and the bottom by 5, so that's 5/5. 5/5 plus 2/5 gives me 7/5. And that is the equation of our normal. So main concepts from today's lesson. Again, a normal is perpendicular to a tangent. To find the slope of a perpendicular or the slope of a normal, we do the opposite reciprocal slope. Opposite means change the sign. Reciprocal means flip the fraction. Once we have our slope and a point, we can plug it into our point-slope form just like we did for equations of tangent lines. There's some problems we can take a look at on page 581, number 1, 3, and 5. Until next time.